Hello and welcome. In this tutorial, we are going to plot accelerometer. Yes, our good old friend accelerometer values using processing. And then we're going to actually also try to plot gyroscope values so we can really see the visual output of this sensor even more so than we did with the previous LED experiment. So to do so, there is actually an Arduino CCEN tutorial graph. There is some code that we can use there. It essentially gives you an example of, like a voltage divider, and you plot that graph. I would go for something even better. I would take our code for the accelerometer and use that eventually. But first, let's just try to highlight this. Processing, graphing, sketch. I think this is where it all starts. That's where it ends. Control C. We put that into processing. We get our Arduino in here. And we work from there. So our port, like we've already done before, is going to be 1 right here. So if I upload this, all we need to do is print a single value, so we can print the value of the accelerometer X. I mean, this delay can be something very small. We can upload this, and it'll be very, very interesting. Question. N-A-N-N-A-N-N-A-N-N-A-N. Plot is at 9600. So there are no type string arguments, line 13. I really don't think we would need to print the serial list. Stop. Press play. Okay. I guess I would need to check if the accelerometer... we are typing the word accelerometer, and I think they just want to read a single numerical value. So we're going to try this thing again and see if this default graph produces a graph. Done uploading, play, and there you have it. All right, so you see I can touch that and the graph goes crazy. So I'm gonna have a look at maybe making this graph bigger, making our value something more meaningful so that the range is between 0 and 1000, because that really is. See, 1023, the height is mapped to 1023. This is the size of the window. So we can go in here, this being the width. I mean, I don't know how many pixels do we got. I can go maybe 1100, 1920 across. I reckon I can go 1100. And the height, I don't know, 650, maybe 11 by 7, like 711. Yeah, so we can do that first. Second, if I remember rightly, the values go all the way up to like 20,000. So to drop them to 1,000, you got to divide it by 20. You can just go AX divided by 20 or AX times 0.05. 0.05. That's like dividing it by 20. All right. So I'm going to upload this and see what kind of numbers I get. I'm looking for 50s, 100s. No luck. That stopped. I may need to create a float that's going to be this. Oh, no, that's perfect. Okay, this could be too low, but we're going to see. We're going to have a look at what this graph now looks like. Nice, big. Okay. And it can go all the way to the top. That's what I was looking for. All right. So I was going to actually like calibrate it like I did before, like set it to 0. But I don't think that's necessary. And you can easily see, like, I can apply a little bit of force. It goes positive and negative. And, you know, rather than going positive and negative, I think we can, like, ABS hit the absolute value here. Steady graph, and we can just apply some force. Right, left. And this only interacts on the x-axis. And x-axis is actually the... No, right, left, up, down. It's the up-down axis. Up and down this way, not so much, but that way. That's where the force is being measured. That is pretty awesome. All right, let's see. I think the most interesting of all would actually be the gyroscope Z, which is the rotation axis. So we can like spin this guy and see what happens visually. And I already got an idea in my mind how we want to do this. So I'm going to not use an absolute value. So I've got to reduce the, I've printed that. So we're going to go for GZ. We're not going absolute. If we times it by 0.05, now we'll times it by like 0.1. And we're going to add 500 to it. Yeah, I think this could work. Let's see. So hopefully we're going to see a line going like through the middle of the graph, and then we can spin the guy. What is your problem, son? All right, looking good. Yes. Watch. Whoosh. Goes down to 0. It's pretty sensitive. It goes all the way up that way. And then goes down to 0. Up, down. Rotation. So we are going to stop there, and I think those are absolutely sensational ways to visualize the output of the accelerometer. In fact, I'll just show you one more thing. If you've ever seen a self-balancing robot, what you're looking at is, in a way, if you think the middle is 0, what you're looking at, the spikes down and the spikes up, that would be the motor output, which balances a self-balancing robot. The exact thing you're seeing on the screen is what happens inside a Segway, right? And the values that are being written up here and down there are the values that are being written to motors to stabilize the robot. So we are going to, in the next tutorial, see if we can do anything at all to smoothen that graph. But for now, that's everything. Have fun and see you in the next tutorial.